Okay, nearly there. Absolutely nearly there. So in the exam right now, feeling good, feeling happy, feeling confident, thinking, right, this is it, on the home stretch. Question 17, trigonometry. Expand and simplify. Now, the minute you see these, again, I would always think to myself, what are my trig identities? Okay, so it's on the side here, I'm just going to write sine. I'll just leave out the x, right? Sine over cos equals tan. Okay, if I know, I won't, just to be, sorry, I shouldn't do that. Shouldn't be lazy. Sine over cos is tan. Okay, that's one identity you need to remember. The other one is that sine squared x plus cos squared x is equal to 1. These are the only two things you really need to learn in that 5. So when we get to a question like this about expanding and simplifying trig, this is what we're thinking on. Just this bit here, I find this quite interesting, thinking about sine and cos in terms of SOHCAHTOA. Okay, and this sometimes can come in helpful when you do these questions, okay? Sine over cos. Right, so sine is the opposite over the hypotenuse, okay? So if we take opposite over hypotenuse, if we divide that by cos, which is adjacent over hypotenuse, what do we get? Well, opposite over hypotenuse divided by adjacent over hypotenuse. That's the same as, isn't it? It's the same as opposite over hypotenuse times hypotenuse over adjacent, because we do our KFC. Okay, when we do dividing, we keep this the same. We flip this and we change that. Keep, flip, change KFC when we divide fractions. Okay, so we cancel out the h's and we're left with over a. Okay, and what's over a? Tan. Okay, I find that quite interesting. Sometimes that's helpful when we do these questions. So just bear that in mind. There's another way of proving that, and it does come in handy. Okay. So sine x plus cos x squared. Some people are going to write sine squared x plus cos squared x, and therefore the answer is 1. Okay, that is disgraceful. Okay, don't be doing that, please. Okay, I think this can happen when we're getting fatigued, we're not thinking, or we see lots of things and take a deep breath and just sit back. Okay, if we'd said that was x plus 5 squared, no one would say the answer to that is x squared plus 25. Okay, nobody. But for some reason, common sense can kind of go out the window when we start dealing with trig. Okay, so for this, I would always do my table. So I would say sine x and cos x, and then sine x and cos x. So sine and sine, sine squared x, cos and cos, cos squared x, sine x, cos x, and sine x, cos x. Okay, so let's rewrite that. Now, usually, if this was a standard like x plus 5, I would do this, add these two, and then write this. So I'm going to do that here as well. Okay, so sine squared x plus 2 sine x cos x plus cos squared x. Alright? And this is where the trig identities come in. Let's cancel these and just say 1, and then say 2 sine x cos x. It's very messy. 2 sine x cos x plus 1. Okay, or 1 plus 1. Okay, nice and straightforward question there. And again, you can see where there's a few pitfalls, but just taking your time and just having a wee think, really quite straightforward. There's only two things they can really ask you here, and it's to do with the sine over cos is tan, and sine squared x plus cos squared x is 1. Okay, so the marks for this one, you're going to get a mark for, let me just check. Yeah, breaking out the bracket, so your first mark for here, pardon me, and the second mark for on the sine squared x is cos squared x. So if nothing else, if you know nothing about trig, you can still break this bracket out and get a mark, get half marks. Get half marks on a trig question for knowing nothing about trig, just for knowing about how to open up brackets. Yeah. So there's always hope. Don't ever look at a question and think, nope, can't do that. Try and do something. Okay. Snowman question. Now, snowman question is a great question. I love this question. I love it because it's very simple, really, right? There's nothing to it, but the way it's been dressed up makes it very complicated, and it really does it really sorts between who's a logical thinker and who really understands what we're talking about, and who can just be even calm under pressure, to know you've put the work in, you can relax, you've got. Okay. So whenever you see circles, always think of Pythagoras. A lot of the time, what we're trying to do here is find triangles inside of circles. Okay, so you see a circle, think Pythagoras, think triangles. Okay, and then also good sketches. Okay, I love a good sketch, and people don't often take the time just to draw a good sketch. Okay, so here's a snowman. We don't care. We're onto this diagram here. This is where it all matters. Let's go down here. Okay, so most of the stuff's in the diagram. The head has got a diameter of 15. That's not anything. So I'm going to write up here 15. Okay, so we know we've done that. The body is part of the larger circle. That's fine. Point T on the circumference. That's fine. A and B, we see that. Okay, so again, lots of words, not a lot of data. The only thing we wanted was the 15. And we're going to calculate the height of the snowman. So we want to calculate, let's use orange for this. Let's find this height here. Okay, so right away I'd be saying to myself, oh, I know what this height is in here. I know that's 15. Okay, so I just need to know this height in here. I'll keep orange for that. Just need to know this height in here. Now, what is that height in there? We're going from the centre of the circle to the circumference. That's the radius, isn't it, of the bigger circle? Okay, so we know this is 15. That's the diameter. So we've got two small radiuses. I want the radius of the bigger one. Okay. So right away, that's worth something to put down, just to get your mind thinking. So how are we going to find this bigger radius when we only know that one little bit of data? So I'll keep the orange pen. What is the radius? Well, that's the radius. That's the radius. Okay. Center to the edge. What we're looking to do here is to tie it into this smaller circle. That's the radius. That's the radius. Okay. So by tying into that smaller circle, we're able to relate it to the data we do know. Okay. We can actually make a right angle triangle here, can't we? If that's 15, we know that's 7.5. We know that's 7.5. And that's the radius that we're trying to find. Okay, so I'm just going to redraw that over here, just a bit bigger. Okay. You have to apologise my pen skills. Okay, so that's the radius we're trying to find. Just put a little right in there, and that's 7.5, and that's 7.5, and that's just from in there. So now I'm just going to rub out all the things that don't really help us. Okay, that was just me chatting away. We don't even need this bit in here, do we? We just need this bit there. Okay, so that is the crux. That's the essence of this question. Okay, so now once we've got this, let's write it out. So let's say the radius is equal to 7.5 squared plus 7.5 squared square root. Okay, Pythagoras add. Let's get our calculators out for that. So what does that give us? 10.6. 10.6. I'll just keep my units consistent as well. We've got centimetres here, so 10.6 centimetres. Okay, so that's the radius. Now, what I thought we'd stop there and think, oh, I'm a genius, I worked that out. But that's not the question, is it? The question is the height of the snowman. Okay, and like we said at the beginning, the height is the 15 plus the 10.6. So, say the h is equal to 10.6 plus 15, which is 25.6 centimeters. Okay, again, this destroyed Twitter. It's all over the place. What we're very upset because it was quite a seemingly complicated question, but you can see here, it's really not. You just need to know what you're looking for. When you see circles, think triangles. Okay, so the first mark you're going to get for this is this triangle here. That is, that is worth a mark. Congratulations. The next step is working out R. Okay, so you get a mark for knowing what Pythagoras is, and then a mark for actually following it through, and then another mark for adding the height on. Okay, that's pretty good. That's absolutely fantastic. I don't know if you would actually get a mark if you just said made up a number and added 15 to it. You actually possibly would, to be honest. Write down as much as you can. But I think the key here is have a look at your diagram, make some rough sketches, and then just remember Pythagoras and triangles. Okay, and don't panic. Okay, good stuff. Thanks very much.